Okay, another method that we can use to solve systems of equations is by using determinants and Cramer's rule. The first thing we're going to do is practice finding a determinant so that we can apply that to Cramer's rule. Now, a determinant is the value of a matrix. So if I'm looking at this matrix, this is a 2 by 2 matrix, and so if I want to find the determinant of this, we follow the pattern. The pattern for this determinant that we're looking at is multiply to the right diagonal, then subtract, multiply to the left diagonal. So this gives us a -3 times 8 minus 4 times 6. So this is -24 minus 24. So this one is a -48. So my determinant for this problem is -48. That's it. It's just simply that pattern, right minus left. That's what you're going with. So you're going to take your right when you multiply it together and subtract what you get whenever you multiply the terms from the left together. Cool, let's check this out. We can also do a 3 by 3 matrix, and not just a 2 by 2, so we can also do a 3 by 3 matrix. Now, this is how I found that works a little bit better. This is different than how your book shows you, and we're not going to be using cofactors at this point, but as I've taught this, it seems like this method students understand better because it's still the concept of right minus left. So we're still going with the same concept here. Now, however, if you notice, I can have a right coming here, but whenever I try to do this right, I run out of terms. So because of that, we're going to rewrite those first two columns. So I have 2, -1, -1, -3, -4, 0. So whenever you're working through these problems, now you have the right, all three of those are going to be the right value, and then you'll be able to subtract the left. So for a 3 by 3 matrix, you're going to have 3 terms on your right diagonal minus 3 terms on your left diagonal. So for your right diagonal, if I do this first line that we have here, 2 times -4 times 2, what I like to do is write the number on the small at the bottom so that I can kind of keep track of it. So then that's going to give me a -16. Then I'm going to do my next diagonal. -3 times -3 is 9. 9 times -1 is a -9. And then anything times 0 is 0. So that makes it handy. So for my right, I have -16 plus a -9 plus 0, because we'll add all of those together, minus, then we'll see what we have here with our left. So with our left terms, we're going to go down diagonal, diagonal, diagonal. So in the first one, -2 times -4 is +8, times -1 will give me a -8. For the second one, anything times 0 is 0. And for the third one, -3 times -1 is 3. 3 times 2 is 6. So I have -8 plus 0 plus 6. So you're adding up the terms in the diagonals. So you're adding up all the right minus adding up all the left. So on the right, I have -25 minus, and then on the left, I have a -2. So minus a negative, we add the opposite. So the value of this matrix is a -23. That's our determinant. It's just a pattern. And always remember, it's just the right minus the left so that you have that same pattern, whether it's a 2 by 2 or a 3 by 3. If you look in, help me solve this, and you come up with the cofactors and you like that method, use it. There's nothing wrong with that. That's a great method. But I found that whenever I've taught this in the past, it just makes it easier if you go with the same thing. So go with the same thing over and over. Makes it easier for students. Okay, let's try some more. Now here is what Cramer's rule actually is. So Cramer's rule for two equations and two variables. The same holds true for equations with three variables, your x, y, z. Same holds true for Cramer here. So you're given this system. The A, the B, and the C here, this A, B, and C, those are just numbers. So the 1 happens because it's the first equation. The 2's happen because it's the second equation. Now, to get the D here, so this D happens whenever you take the actual left side. So the A's and the B's, the coefficients of the X and the Y, that's how you get your basic D. And you'll divide each determinant by that. Then to specifically get the dx, so the determinant here with x involved, you're going to replace the x column with this answer column. So whichever variable it is that you're solving for, you're going to replace that column with the answer, leaving the other column the same. Like for this dy, you left the first column the same, and you replaced your answer with the y column. See what I'm saying? So that's the same as your actual d, but when you find the determinant of x, replace the x column. When you find the determinant of y, replace the y column. That's it. Then find that determinant. The beauty of Cramer's rule, especially whenever you get some of these numbers, sometimes your answers aren't just nice little integers like what we've been working with so far. So Cramer's rule works really nice whenever you have those freaky answers. But a point that needs to be made here. Notice this down here in red. Cramer's rule can't be used with no solution or infinite solution problems. So it cannot be used with either one of those scenarios. You're going to have to choose a different method. You'll have to do substitution or elimination at that point. So Cramer's rule has its bounds. So you'll know that Cramer's rule can't be used because the determinant here will equal 0. If your determinant equals 0, Cramer's rule can't be used because you can't go through and divide by a 0. Cool. Otherwise, we're going to rock the socks off Cramer's rule. Let's try some on. Okay, here's a system of equation. Let's use Cramer's rule to pull this off. In order to use Cramer's rule, the first thing we want to do is we're going to set the x's and y's into a matrix that's just going to be our D. So 5, 7, 6, and 8. So we have this matrix that we're looking at, and we'll use our determinant for that. Then, well, let's do this one first. Let's go ahead and just do left minus right. So we have 5 times 8 minus 7 times 6. So 5 times 8 is 40, minus a 42. My determinant here for D is going to equal -2. So there's our first one. Then we're going to have our determinant of x. Now remember, whenever I solve the determinant of x, the y column stays exactly the same, but because x is what I'm trying to find, I'm going to put my answer in that column. So -1 and 1, so your answer goes in the column that you're trying to figure out. Then you find that determinant. So I have -1 times 8 minus 7 times 1. So -8 minus 7. The determinant of x is a -15. Now let's figure out the y. So the determinant of y means that my first column stays the same of 5, 6. But then I put the answer in that y column, which is -1, 1. And then you find that determinant again. 5 times 1 minus a -1 times 6. So 5 minus a -6. So the determinant of y is going to equal 11. Awesome. Now, here is where we come up with those actual values. So the x value here is going to be the determinant of x divided by the regular determinant. So my x coordinate is negative 15 divided by a negative 2. So my x value here is 15 halves. The determinant of y, y is going to be the determinant of y divided by my actual determinant. So I have 11 divided by negative 2, and that is simplified. So just like with every other system of equation, you want to write your final answer as a coordinate point. So my answer for this problem is going to be positive 15 halves and negative 11 halves. And there it is. Now notice for Cramer here, that's where it's kind of that crazy answer. But that's the beauty of Cramer, because notice my whole work, I dealt with an integer of negative 2, an integer of negative 15, and an integer of 11. My answer didn't get crazy until the very end when we do that division. Cool, let's do some more.